Have you ever looked at a world map and thought, do these continents fit together like puzzle pieces? Look at South America and Africa. See how their edges seem to match? It's almost like they were once connected. But wait, how could entire continents move? Did the Earth change over time? Or is this just a big coincidence? Well, a scientist named Alfred Wegener had the same question over 100 years ago. And what he discovered changed the way we see our planet. Let's go back in time and find out if South America and Africa seem to fit together like a puzzle. Could other continents have been connected too? Scientists started to wonder when they looked closer. They saw something amazing. North America and Europe, India and Madagascar. The edges of many continents look like they once belonged together. And it wasn't just their shapes. Scientists found that the rocks along these coastlines were the same kind and the same age, even though they were now separated by vast oceans. But here's where it gets even weirder. Fossils of the same ancient plants and animals were found on completely different continents. How could a dinosaur have walked from Africa to South America without a bridge? Something didn't add up. Scientists knew these creatures couldn't have swum across the ocean. So, was it possible the land itself had moved? This mystery puzzled scientists for years. But one man, Alfred Wegener, believed he had found the answer, and his idea would change everything. Alfred Wegener had a groundbreaking idea. Long ago, all our continents were joined together in one enormous landmass called Pangaea. Imagine a supercontinent where every piece of land fit perfectly, like one giant puzzle covering the entire globe. Over millions of years, Pangaea began to crack and break apart. These massive pieces slowly drifted away, eventually forming the continents we see today. Wegener believed that powerful forces deep within the Earth pushed these enormous chunks apart, much like a gentle but steady pull that shifts a puzzle piece. His theory, known as Continental drift, was revolutionary. It challenged the old belief that the continents were fixed in place and unchanging. Today, modern science confirms that the Earth's surface is always moving, and Wegener's bold insight was the first step toward understanding our dynamic planet. Wegener needed proof, and he found it. Fossils of the same ancient plants and animals were discovered on continents now separated by vast oceans. Take Mesosaurus, for example. This small reptile lived only in freshwater, yet its fossils were found in both South America and Africa. There's no way it could have swum across the salty Atlantic Ocean. But that's not all. Scientists also found identical rock layers on different continents. A mountain range in South America matched perfectly with one in Africa, as if they were once connected. Even ancient glaciers left clues. Scratches carved into rocks by massive sheets of ice were found in places that are now hot and tropical. The only explanation? Those lands used to be much farther south, closer to the icy poles. With all this evidence, fossils, rocks, and climate clues, it seemed clear that continents had to have moved. But back then, many scientists weren't convinced. Wegener's idea was bold. But there was one big problem. How could entire continents drift across the Earth? No one had an answer, yet. Wegener was excited about his discovery. He had evidence, maps, and fossils, all pointing to one conclusion. The continents were drifting apart. But other scientists weren't convinced. The idea of moving continents seemed impossible. After all, no one had ever seen land shifting. Wegener's theory had one major flaw. He couldn't explain how these giant landmasses moved. What force could possibly push entire continents? Without a clear mechanism, most scientists rejected the idea. They argued that continents were too heavy to plow through the ocean floor. Despite the criticism, Wegener stood by his theory. He believed the evidence spoke for itself, even if he didn't have all the answers yet. For years, Wegener's idea remained controversial. But then, decades later, new discoveries would finally prove he was right all along. Decades after Wegener's time, scientists made an incredible discovery deep under the ocean: giant cracks running along the seafloor. These cracks, called mid-ocean ridges, were spreading apart, creating new seafloor. It was as if the ocean floor was slowly moving. Scientists realized that Earth's crust isn't one solid piece. It's made of huge moving plates that float on molten rock beneath the surface. These plates are constantly shifting, some pulling apart, others crashing together, causing earthquakes, volcanoes, and even mountain formation. This was the missing piece of Wegener's puzzle. His idea of drifting continents was real, driven by the powerful forces of plate tectonics. With this discovery, scientists finally understood how continents move. Wegener's idea, once rejected, became one of the most important theories in Earth science. To prove the theory of plate tectonics, scientists turned to the ocean. What they found beneath the waves was astonishing. At the mid-ocean ridges, molten rock was rising, creating new ocean floor. This meant the seafloor was slowly spreading apart. Even more amazing, scientists found magnetic stripes on the seafloor. These stripes showed that Earth's magnetic field had flipped many times over millions of years. This proved that new seafloor was forming, while older seafloor was being pushed away. The continents weren't just drifting, they were carried by moving plates. But where does the old ocean floor go? Scientists found deep trenches where seafloor sinks back into the Earth, like a giant recycling system. With all this evidence, there was no doubt the continents had been moving all along. The mystery Wegener started had finally been solved. Guess what? The continents haven't stopped moving. Even today, they drift at about the same speed as your fingernails grow, just a few centimeters per year. Thanks to satellites and GPS, scientists can track these slow movements. They can see North America moving west and Africa shifting east. Over millions of years, this movement adds up. One day, continents could collide to form a new supercontinent, just like they did in the past. These shifting plates shape our world. They create mountains, trigger earthquakes, and even cause volcanic eruptions. Imagine the Earth millions of years from now. Will there be a new Pangea? Will some continents disappear? Scientists are still figuring it out. One thing's for sure, the Earth is not standing still. It's a dynamic living planet, always shifting, always changing, and we are lucky to be part of its incredible story. The movement of continents isn't just history, it's still happening. The Earth is always changing, shaping the world we live in. Understanding plate tectonics helps us predict earthquakes, study volcanoes, and even find fossils that tell the story of life on Earth. We may not feel the ground moving, but over time, our world will look completely different. The continents have traveled an incredible journey,